Okay, what is color? You'd think we'd have this all figured out by now. For centuries, the answer seemed simple, all thanks to Isaac Newton's famous Prism experiment. But what if that's only half the story? Today, we're diving into one of the greatest and most overlooked intellectual battles in the history of science, a total clash between a physicist and a poet over the very nature of light itself.
And yeah, this was no friendly disagreement. The great poet Johann Wolfgang von Goethe, he looked at Newton's theory not as some brilliant breakthrough, but as a nest of rats and owls. He wasn't just trying to make a few corrections, he was trying to tear the whole building down. So let's dig in and see what got him so fired up.
All right, here's how we're going to break it all down. First, we'll set up the classic clash, Newton versus Goethe. Then we'll dive into Goethe's side of the argument, and that's going to lead us to a very specific puzzle, the problem with the color green. From there, we'll jump into a really modern theory that totally rethinks the photon, introduces a wild concept called the charge field, and believe it or not, tries to build a whole new theory of light. So let's set the stage for our first round, Newton versus Goethe. And this isn't just about prisms and rainbows. Nope. This is a fundamental disagreement about how we even perceive reality, fought between two of the absolute giants of history. You know this story. We all learned it in science class, right? Isaac Newton, way back in 1666, he's in a dark room, lets in a single beam of sunlight, and puts a prism in its path. And bam! He reveals this beautiful rainbow that was supposedly hiding inside that pure white light all along. It's simple, it's elegant, and it's been the foundation of optics pretty much ever since. But here is where the real fight begins. See, for Newton, that prism is basically a detective. It's just separating and revealing the colors that were already there, packed into the white light. But for Goethe, the prism is more like an artist. It's an active participant. It actually helps create the colors from a dynamic dance between light and darkness. These are two completely different ways of looking at the world.
So how in the world did a poet think he could take on Isaac Newton? Well, Goethe didn't just have philosophical objections. He did his own experiments, and he got some very, very strange results. Results that, frankly, Newton's theory has a really tough time explaining.
And this was Goethe's eureka moment. He looked through a prism at a big white wall, and you know what he saw? Nothing. Just a white wall. It was only when he looked at an edge, like a dark window frame against a bright sky, that all the colors suddenly appeared. And this led him to ask a totally radical question. What if color isn't in the light at all? What if it's only generated at the boundary between light and darkness?
And he proved it with this incredibly simple experiment. See, instead of a tiny little pinhole of light like Newton used, Goethe used a much wider slit. And when you do that, you don't get a full rainbow right away. What you get are two distinct sets of colors appearing at the edges. You get yellow and red on one side, and cyan and violet on the other. And in between, just plain old white light. The full rainbow only shows up when you move your screen back far enough for those two colored edges to finally overlap. Now that overlap, that's where green appears. And this brings us right to the heart of the mystery, the big puzzle of this whole explainer, the problem with green. It's the color that sits right in the middle of the rainbow, but the source material we're looking at argues it just might be the key to understanding how we've gotten color all wrong for hundreds of years. Okay, check out these clues. It's kind of like a detective story. First, we all know magenta isn't a real color on the spectrum, right? It's an optical illusion, a mix of red and violet light. Well, this theory we're exploring claims that green is exactly the same thing. It's a mix, not a fundamental color. And the biggest clue? Colorblindness. The most common forms involve trouble seeing green. But think about this. If green were its own primary color, why would a defect in your red cone cells make you unable to see green? It just doesn't quite add up.
And that brings us to the core thesis of this whole idea, a direct and pretty shocking claim from the physicist Miles Mathis. He says green is not a wavelength of the photon. Green light is a mixture of yellow and cyan light, and it is created in the eye. Let that sink in. He's saying the green you see isn't some green photon hitting your eyeball. No, it's your brain's interpretation of seeing a yellow photon and a cyan photon at the exact same time. Now, to even begin to explain that, you have to go way deeper than just looking at prisms. The source material for this proposes a whole new mechanics for the photon itself. We're not just challenging Newton anymore. This goes up against a lot of modern physics, too. Okay, so the foundational idea here is called quantized photon spin.
I know, that sounds super complicated, but stick with me. The core idea is actually simple. Forget thinking about a photon's energy as being on some smooth, continuous ramp. This theory says that photons have a real, physical spin, and the energy of that spin can only exist in very specific, discrete steps, like a staircase. You can be on step 1, or step 2, or step 4, but you can never, ever be on step 1.5.
And if those discrete energy levels are real, it leads to an absolutely mind-blowing conclusion. The theory calculates that because of those specific steps, matter can only directly emit photons at 2 specific energy levels that we can see. This means that every single color we see in the entire universe, it all originates from just 2 fundamental types of photons, red and violet. That's it.
So, the obvious question is, if everything just starts as red and violet, where does the rest of the rainbow come from? Well, that brings us to the next big mechanism in this theory, explaining color with something called the charge field.
What on earth is a charge field? Well, the theory proposes that all matter, I'm talking the walls, the air, the prism itself, is constantly emitting this huge sea of its own tiny, low-energy photons. Imagine it's like you're trying to walk through a swimming pool instead of through empty air. Space isn't empty. It's this active field that can literally, physically interact with and push on the light that's traveling through it. And here's how that push actually creates new colors. It's a simple process. Step 1, an atom somewhere emits a fundamental red or a violet photon. Step 2, that photon travels through this charge field and gets pushed on. Step 3, that little push changes the spin energy of a red photon and it shifts it, turning it into a yellow photon. And step 4, the same exact thing happens to a violet photon. The push from the charge field shifts it and it becomes a cyan photon. And just like that, our 2 emitted colors have become 4 distinct colors we can actually see. Okay, so let's put all the pieces together. Let's see how this all combines into a new theory of light. One that actually tries to unify the best points from both Newton and Goethe to finally solve these color mysteries that have been around for centuries. This table lays it all out perfectly. At the very top, you've got your 2 fundamental colors, red and violet. These are the ones that are directly emitted by matter. Then you've got your secondary colors, yellow and cyan. These are created when that charge field pushes on and shifts the fundamentals. And finally, you have the tertiary colors, green and magenta, which this theory says don't even exist as their own photons. They are purely optical illusions, mixtures created inside your eye. And there it is, the direct solution to our central puzzle. Green isn't fundamental. It's what your brain cooks up when a yellow photon and a cyan photon hit your retina in the same spot at the same time. Yellow plus cyan equals the perception of green. But here's what's really wild. This theory also explains Goethe's weirdest experiments. Remember how he created colors from the edge of a shadow? This theory claims that the boundary between a light area and a dark area creates a kind of density difference in that photon field. And that difference acts just like the physical edge of a glass prism, allowing colors to be sorted out and created from nothing but an edge. So, what does this all mean? We just walked through a theory that was born from a 200-year-old debate between a poet and a physicist, and it claims that a simple little prism experiment can challenge a major cornerstone of modern physics. It really forces you to ask a fascinating, maybe even a little bit of an unsettling question. What other settled science might not be so settled after all?